Hi again and welcome to this me versus maths tutorial on trigonometry in right angle triangles. This is actually the third tutorial in this series, but in a way this is where things really get started. We'll be using the foundations we've built in the previous two tutorials to start to find missing sides in triangles. So without further ado, let's get going. Here then are our trig formulas. Remember from last time, we can use SOHCAHTOA as a shorthand to help us remember these throughout this topic. Okay, this is a standard kind of trigonometry question. We've been given a right angle triangle and we're being asked to find a missing side. In this case, the one labelled D. Step 1 is to label our sides. I'm not going to spend ages on this as we have a whole tutorial dedicated to this part. The hypotenuse is opposite the right angle, the opposite is opposite the active angle in our question, which is the 29 degrees, and the adjacent is the one left over. Step 2, once we've labelled our sides, we identify our active sides. We've been given the hypotenuse, and we are looking for the adjacent. So these are our two active sides in this question. Okay, we then look at our trig formulas and see which of these contains both the adjacent and the hypotenuse. It's not SO, as that uses the opposite, it is CA, as that uses our two active sides. The next step is to write our formula properly out in full. So in this case, cos theta equals adjacent divided by hypotenuse. And now we'll start to put some values into this formula, or in math speak, we're going to substitute values into this formula. So, cos theta. Remember, theta is the symbol used to represent our active angle. So in this question, cos theta means cos 29. And that is equal to the adjacent divided by the hypotenuse. So for our triangle, the adjacent is called D, and it's divided by the hypotenuse, which is 7.8. Just take a moment there and check you're happy with what we've just done. If not, just rewind sort of 30 seconds and watch that bit again because it's very important. Right, we're getting somewhere. We want to know the value of D. Now at the moment, D is being divided by 7.8, so to get D on its own, we need to multiply by 7.8, and that's both sides of our equation. These are a lot of the same skills you'll have used in the past when solving equations. So 7.8 times cos 29 will be equal to side D. This is where your calculator earns its money. You can type this calculation, everything on the left hand side, into a calculator exactly as it looks here, and it will work it out for you. If you've got a calculator where this doesn't work and you need a bit more help, then just ask in the comments and I'll do my best to help. Okay, if it works correctly then, you should get an answer for 7.8 times cos 29 of 6.8220 and lots more digits besides. If we round that off to one decimal place, D is equal to 6.8 centimetres. Okay, we've just used trigonometry to find a missing side in a triangle. Right, let's look at another example. The more of these you do, the more you get comfortable with it. It really is something where it's worth having a lot of practice. First step, I'm going to label up my sides nice and quickly, like so. And now I'm going to identify my active sides. We're given the adjacent, and we're looking for the opposite. So these are the two sides that we'll be using. So we're looking for the formula that contains an O and an A, which we can see is tan. So let's write that formula now out in full. As before then, let's now substitute our values in. Tan theta, the angle, which is 38 in this question, is equal to the opposite, which we're calling T, over the adjacent, which for this triangle is 3.1. So we're looking for T, which is being divided by 3.1, so we need to multiply both sides by 3.1. So we have 3.1 times tan 38, which is equal to T. So just as last time, if you've got a good calculator, type 3.1 times tan 38 in, and you should get an answer which rounded off will give you t is equal to 2.4 meters. On to another example now. This may look the same, but we'll see in a moment that it's actually a little bit different. Step 1 though has not changed. Let's label our sides up. Step 2 and 3 are just the same as well. Identify our active sides and decide which formula we're going to use. In this case, we'll be using sine or sin, so let's write that formula out in full. So far then, no change. Let's substitute our values in and see where the difference is going to lie. So sine 64, as that's our angle, is equal to the opposite, which is 17.3, over the hypotenuse, which in our question is called y, and is what we are looking for. Notice that this time the side we want is not on top of this division, but is underneath. Now to deal with this, there is a little trick that we can use, and I like to call it the old switcheroo. Watch carefully now, as we are going to switch the sine 64 with the y. Let me show you that again. We're switching the sine 64 with the y. Okay, we'll put it back as it were, and in terms of showing it on my working out, I'll just draw that arrow on to show the switch and then show the result of that switch. Now it looks like a lot there on the right hand side, but that is something that again modern calculators will happily work out for you in one go. If you have one of the Casio calculators, for example, I would suggest that you use the fraction button and then enter the 17.3 over sine 64 as a fraction, exactly as it appears there. If you do that, you will get an answer that rounded off gives 19.2 centimeters. One more example like that then, and we'll do most of this really quickly. Label our sides first of all, identify our active sides, and decide on the formula which we're going to use, which in this case is tan. Write out the formula, substitute our values in. It's the opposite divided by the adjacent, so 3.9 divided by z. Okay, what we're looking for is on the bottom, so we need to perform the old switcheroo trick again. Let's just visualize that once more. So we're swapping the z and the tan 19. In terms of our working out, we'll use the arrow again to show what we're doing and then perform the swap. As before, we can now enter everything on the right hand side into a good calculator in one go, and that will give us an answer of 11.32 and so on, which we can round off to one decimal place to give 11.3 meters. Right, that was hard work, wasn't it? Well done with sticking with it till the end. In our next tutorial, we'll move on to finding angles, which in my opinion is actually a bit quicker and easier. If you're not there already, remember to check out the website at meversusmaths.com, where you can find lots more resources, including some to help you practice the skills that you've just learned in this tutorial here. Thanks again for watching, enjoy the rest of your day, and bye for now.